Hi guys, welcome back to my YouTube channel. Today I'm going to talk about network basic, which means this is the first video of networking video series. Guys, let's go to the first slide. Okay, what is a network? It's a collection of computers, servers, network devices to share data between each other. Network devices. For network devices, routers, firewalls, switches, servers, and computers. So you can see a simple diagram in the screen. So you can see a PC, which IP there is IP address, and there are two PCs, which there are two IP addresses, and you can see a switch. These PCs are connected to the switch, and there is a server with 192.168.1.2 IP address, and also there are router top of the diagram. So this is the diagram I was copied from the Cisco packet tracer. So guys, don't worry if you don't know these components, what means by these components. I will discuss everything in future videos, so don't worry about it. So guys, now you can see a very simple network in my screen. So a laptop is connected with a PC using the Ethernet cable. We call it RJ45 cable. So you guys think, what is RJ45 cable? So don't worry guys, I will show RJ45 cable in future videos, and then you can have a look. And also I will teach you how to connect a laptop with a PC using RJ45 cable. So this is a very simple network connecting two devices using RJ45 cable. And also we can say a simple network as if you connected your mobile with another mobile using Bluetooth, it's also a network. And if you connect with your mobile with a PC, it also a network. So guys, let's go to the next slide. Okay, so you can see that there are more than two computers. So in this kind of situation, we have to use a switcher hub to connect these devices. Okay guys, so this is an example for more than one computers. Okay, so what is IP address? Now I'm going to talk about IP address, but I'm going to talk in a very basic idea about IP address, because IP address is very important when you are going to learn networking. It's a logical address to identify or locate a machine. So guys, what does it mean? You know guys, when you connect with the network, you have never thought about a IP address. Guys, to connect a device with a network, it must have a IP address. I'm talking about a network connected with routers and switches. Okay, it's not about connecting devices using Bluetooth like. So guys, IP address means it's a logical address to identify or locate a machine. So if my computer is connected with a router, then my computer has IP address, and also router has IP address. The required communication is done between each devices. So IP addresses help us to identify or locate a machine in a network. Okay, so there are two types of IP addresses, IPv4 and IPv6. Why there are two types? IPv4 is 32-bit IP address. What's a bit? We have talk about bits and bytes. So bit is the smallest units of data representation. So it may be it's a logical representation. We call it 0 or 1. So bit is a binary number. It can be 1, it can be 0. So that's the we were for a bit. So guys, IPv4 address has 32 bits. In these 32 bits, it has separated by dots up to 8 bits. So you can see 4 8 bits part in a IPv4 address. Then, but you know guys, the 32-bit address is very difficult to identify for a human. So that's there is another representation. We call it dot decimal notation. So we convert every and each 8-bit parts into a decimal number. So then we represent as a dotted decimal notation. So in this screen, you can see numeric dot decimal notation 192.160.5.8. So this is the example for a IPv4 address. So guys, you know that there are 32 bits and 8 bits are separated by dots. So then you have four 8-bit parts. So that's a representation of IPv4 address. Then you think, so how much IPv4 address we can create? So think guys, there is a limitation because you have only 32-bit on your IPv4 address. So that's why IPv4 was introduced in 1998. So it's a 120-bit IP address. So it's a hexadecimal notation. So then you guys, you know that in every and each day there are new devices connected with the internet. So internet is growing day by day. So that's why IPv6 was introduced after IPv4. But IPv4 is still enough to use in internet. So in but already now IPv6 is using, but IPv4 still has a lot of IPs to use. Okay, guys. Okay. Actually, in this video, we're going to talk about only IPv4. So we will talk about IPv6 in later because at the moment we are using IPv4 in our industry most of the time. But I don't mean that we are not using IPv6. We are using IPv6, but most time we are using IPv4. That's why I'm going to talk about IPv4 here. It's a 32-bit address. So you can see that the 8 bits separated by dots. So you can see there are four 8-bit parts. So one of these 8-bit part we call as a octet. So there are four octet for a 32-bit IPv4 address. So we need to represent it in a easiest way. So that's why we represent this 32-bit IP address as a dotted decimal number. So guys, in the example row, you can see 192.160.64.1. In the brackets, you can see the binary view of this IPv4 address 1100000 dot 1010000 dot 010000 dot 000001. So this is the binary notation of the IPv4 address. So guys, I hope that you have an idea to convert binary numbers to decimal number. So from the left hand side, I select the first 8 bits. So then I convert into decimal number. So it gives the number of 192. Then I go to the second part. So when I convert into the decimal number, it's 160. So then I go to the third section. So then I convert this to decimal number. So it's 64. The last part, last octet, we convert into the decimal format. So it gives 1. So that's why the IP address is 192.160.64.1. Okay, so this is another view for IP address. You have 32 bits, but these 32 bits are separated by dots, and one part include 8 bits. So you can see there are 4 section with 8 bits. So total number of bits are 32. So we call one of a 8-bit part as a octet. So guys, this is in my screen you can see there are 4 octet in IPv4 address, first octet, second octet, third octet and fourth octet. So and also you can see a example for this. Okay guys, now we are going to talk about a very important part. So here we are going to talk about OSI model and TCP IP model. So guys, before coming to this section, I have to say some story. In the past time, if you buy a mouse from company A and you buy a computer from company B. So these two devices were not compatible. So if you bought a computer from the company A, you have to bought a mouse from same company, because the computer from company A was not compatible with mouse from company B. So that was a big issue in past VPAs. So after that, in international standard organization we call ISO introduced a model and instructions, set of standards for these as a solution. So we call that OSI model, and parallelly it was introduced TCP IP model, but same theory is applied there. Okay, let's go to the next slide. You can have a look on my screen from the left hand side to right hand side. You can see OSI reference model and TCP ICP model. So here I'm going to talk about OSI model. So you can see there are 7 layers. So the from the top to bottom, you can see layer 7, layer 6, layer 5, layer 4, layer 3, layer 2, and layer 1. If someone is asking from you what is the layer 7, you must say it's application layer. It is on the top of this diagram. So then presentation layer is the layer 6, session layer is the layer 5, transport layer is the layer 4, network layer is the layer 3, data link layer is the data layer 2, physical layer is the layer 1. Okay guys, let's talk more. Okay, what is application layer? I know you guys are already working with application layer. Without application layer, there is no flow of data. So guys, what is an application layer? Does it mean application? Guys, it is not the application, but application helps you to work with application layer. So as some example, your browser, your Outlook application, your Skype application, and any other application example. So these application help us to work with, if not interact with, application layer. So what is application layer? So it includes set of protocols. Okay, so guys, if you do the web browsing, the HTTP protocol helps you. So these are examples for the application layer protocol. If you send emails, it helps SMTP protocol for you. If you share files, if you upload files, and then if you working with files transferring, then it helps FTP protocol for you. So this is uh, examples for application layer protocols. So guys, when you work with application, application layer protocols helps you to make your works easier. So guys, let's go to the next slide. So basically, what are the application layer protocols? For file transfer in FTP, for web server in HTTPS, for emails SMTP, virtual terminal, it's use telnet. So you guys think what does it mean by FTP? What does it mean by HTTPS? What does it mean by SMTP? What does it mean by telnet? Don't worry guys, I will talk about these protocols in the next in future videos. So don't worry. Okay, so actually guys, so I'm here trying to teach you how data flow happens from layer 7 to layer 1. So it's a one direction. Let's say you are using application. So you are using some application. Let's say you are using your Outlook application, any other application. So you are sending a message to one of your friend in over the internet. So guys, in that situation, there is a data flow from application layer to uh, physical layer on your computer, then from receiver's end, physical layer to application layer. So here I'm trying to teach you that data flow. So that's why I started from application layer. So our layer 6 is presentation layer. So let's say that you type a message on your application layer in one of your application. So data comes to presentation layer. So guys, then you receive data from application layer to presentation layer. So you input data in the human readable format. So there should be a conversion. Guys, one thing to remember that computers are unable to read human readable languages. Computers can read only machine readable format, which is binary formats. We call 1 a 0. Only that is the language computer can read. So presentation layer here do the job, and it converts human readable language to a binary format, which is a machine readable language. Okay, and let's talk about the complete job of presentation layer. Into the translation, the human readable to machine readable, which is binary format, and also do the data compression. There are a lot of bits on the received data. So presentation layer does the job of compression, reduce the size of bits, and also do the encryption and decryption. What is encryption? So guys, when we work with data, the someone from outside can read our data. So if we encrypt data, they are unable to read the data. So that's what we are calling as encryption. So the some of presentation layer protocols used for the encryption is SSL protocol. So then decryption, so and use the same technique, then do the decryption, which is encrypted data is decrypted. So this is the major functions of presentation layer. Do the translation, do the data compression, do the encryption and decryption. Session layer. So layer 5 is the session layer. So you receive from data from presentation layer to session layer. Okay guys, so let's talk about what is the job of the session layer. The major function of session layer is authentication, authorization, and session management. So session layer helps us to setting up and managing connection, enabling sending and receiving data, followed by termination of connection. Okay, so basically session layer helps us to setting up connection between devices in the network. So that's one of a job of session layer. So then authentication. What is authentication? When you connect with a server, it is asking for the authentication. It asks for the enter the username and to enter the password. So this is what we call authentication. Then what is authorization? So with authorization, it gives access to the file level. So let's say you can create authorization for few users with some restriction. So that's we call authorization. So we can set to read the files. If not, we can set you don't have permission to read this file. So we call this authorization. So major function of session layer is authentication, authorization, session management. Okay, transport layer. So guys, this is a very important layer. So as I mentioned earlier, we are talking about the data flow from application layer to physical layer. So you have application, you type some message and you present it. So then how data flow happens? So that's what we are going to that's what we are talking here. From the application layer to presentation layer, from presentation layer to session layer, it creates sessions and do the authentication and authorization. So then after that we did receive data to transport layer. So guys, what is the major job of transport layer? Segmentation, flow control, and error control. Okay, so when data received transport layer, this data divided into unit, small data unit, we call these it segments. So one job of a transport layer is doing segmentation. So it divides data received from transport layer to a small unit called segments. So each segment contains source and destination port. What is this? And also a session number. So what is the source and destination and port number? So guys, If you try to send data from your computer to another computer, your computer is the source, so other computer is the destination. So then if you are trying to send data using some protocol, using like a uh, uh, FTP, so then it has a separate port number. So if you try to send the mail from your computer to the other one, so it uses a port number called SMTP. The port number is 25. So that's what mean by port number and source and destination. And also, what is sequence number? Sequence number helps query assemble segments in correct order to perform correct message at receiver. So when you send data, so if you have a sequence number in your data, so it helps to it helps to assemble segments in correct order at receiver side. So that's the help of sequence number. So as I mentioned earlier, port number helps to redirect each segment to correct application. So that's what segmentation means. So segmentation means that the received data from the session layer divided into small units, and these segments include a port number and also a sequence number. So what is flow control? Let's say you are going to download something from YouTube. So uh, from the YouTube side, the maximum speed is 50 megabits per second, but your mobile has only 10 megabits per second speed. So guys, this is not compatible. So then you have risk to lost your data while downloading. But guys, the flow control helps here. So it decide which speed used to download data. So you have the lowest speed on your site, on your mobile site, it's 10 megabits per second. So then finally the download speed goes to 10 megabits per second. So it does not try with 50 megabits per second. So this is what we call flow control. Error control. So guys, if some data does not receive at receiver end, transport layer automatically repeat request to transmit corrupted lost data. Okay, if some data does not receive at receiver end, transport layer automatically repeat request to retransmit corrupted lost data. So this is error control. So let's say when you receive data, you have missed some data. So then your transport layer again repeat a request to retransmit corrupted lost data. So this is one of support of our transport layer. We call it error control. So what are the protocols using transport layer? Is we can say TCP and UDP. You have heard about, I think you may have heard about TCP. It's not a problem even you are not heard about these two protocols. We call it TCP and UDP. TCP is transmission control protocol. UDP is user datagram protocol. Okay, there are two type of service from these two protocols. Connection-less transmission using UDP, connection-oriented transmission from TCP. So guys, UDP is faster than TCP because it does not provide the feedback. So what is the feedback? I will talk about it. UDP no feedback does not matter whether we received all data or not. Example: online games, videos, songs, DNS. So when you play these, when you work with these things, you need UDP. So does not matter whether we receive all data or not. Okay. TCP feedback provide so slower than UDP. Full data delivery must like www, World Wide Web, email, and FTP. If you do the file transferring, if you send emails, if you do web surfing, TCP must, because you must uh, deliver full data. Okay, so let's say if you access a website, you must have a full view of that website. So full data delivery must. If you send an email, the full data should be there. If you upload a file, download a file, if you share files using FTP, so then you must share full data. So then for these things, TCP helps us. Okay, guys. So there I talk about the feedback. What is this feedback means, guys? When a TCP connection is established, first send a message. We call it a SYN message. So then receiver, if receiver receive it, he send a SYN plus acknowledgement message. So then again, if sender receive SYN plus acknowledgement message, then he send the acknowledgement. We call this process TCP handshake. So that's what I mean by feedback. So before sharing data, TCP connection should be oriented uh, TCP connection should be established using the three-way handshake. We call this three-way handshake. The sender send the SYN message. If receiver receives SYN, then he send SYN plus acknowledgement message. Then again, if sender receives this SYN plus acknowledgement message, he send an acknowledgement. So after this handshake completed, it is started to share the data. So we call this process TCP three-way handshake. For a UTP, it does not need a handshake. So that's why UDP is faster than TCP. Okay, so transport layer involving segmentation. We call it segmentation. What is segmentation? We talk about that. The data receives from session layer divided into a small unit called segment. It includes port number, sequence number, and that's what we call segmentation. So flow control. So it handled the internet speed and it correct the internet speed. It can download the speed and upload speed. Error control. If you lost any data, then transport layer retry to get these data. So that's what we call error control. Connection oriented and connectionless transmission. That's what TCP UDP protocols help for that. Okay, guys, now we are going to talk about a very important layer. We call it network layer, layer number 3, layer 3. So from the transport layer, we receive data in form of segments. From the network layer, the network layer, network layer make this data as packets. Okay, it convert these segments into packets. So what is a packet? A packet include source IP address and destination IP address. So that's what we call a packet. So why it includes source IP address and destination IP address? Because the job of the network layer is transmission data segments from one computer to another computer in different network. So that's the job of the network layer. So when network layer receives data from transport layer, it convert this data into packets. What happened there? It includes source IP address and destination IP address to the segment. So then we call this data type as packets. Okay. The function of network layer is logical addressing, IP addressing, because when we receive data from the transport layer, this data we call segments. Then this network layer add source IP address and destination IP address. We call it IP addressing. Then other function is routing and path determination. Okay. I will talk again about IP address. In every computers in the network has unique IP address as we talked earlier. Network layer assigns send and receive IP address to each segment to form an IP packet. Okay, that's what we talk. IP address ensure that each packet can reach correct destination. So we already talked about that. Routing. Routing is a method of moving packets from one source to destination. It is based on IPv4, IPv6. Guys, have a look on my diagram. On the bottom, you can see a rectangular box, server A with two network interface cards. Okay, so it means that this server has two interface card. It means if you have two interface card, you have two IP addresses. Then it is connected with two devices with a circular symbol. So we call, let's say it's a router. So you are connected with two routers. So guys, let's say there is a server B on the right hand side. It is connected with router on the top. So from server A, you need to send data to server B. So you can see the path on your diagram. But thing is, server A has two interfaces. So how data decide, oh, if I need to send data to server B, which path I should use? So on that time, the routing helps to transmit data in correct path. Let's say server A send data in 172.20.17.7 net using that network interface card. So then data goes on wrong path. But if server send data in through the interface card which has IP address 192.168.1.12, okay guys, then it is the correct path. But we should give an instruction to if you need to send data to server B, which has IP address of 10.245.13.8, you must use this interface path. So that's what we call routing. So you can, if you are using the Linux server, you can add the routing using a very simple command. That command say, if you going to reach server B which has IP address 10.245.13.8, you should go via 192.168.1 gateway. So guys, you can see my server A has IP address of 192.168.1.12 IP address. Then it is connected with router of the top of the diagram which has IP address of 192.168.1.1. So that's correct. If you need to reach the server B, first you must go to the 192.168.11. So that's routing. So then data will send using this path. After router receives this data, there should be a routing on your router also. Then it will send data to server B. So that's what we call routing. It helps us to say the correct path which data should be sent. Okay, path determination. Path determination is if you have several paths to send data. So it's not routing, but it's similar to routing. So let's say routing helps us to decide paths. But path determination means that you have several paths to send data. Then path determination helps us to select the easiest path. So that's what we call path determination. So as example protocols, we can say OSF, BGP, IS-IS. So these are example for protocols. Okay, now we are going to talk about the layer 6 data link layer. So guys, I'm talking about the data flow from application layer to physical layer. So if you type a message using application one of your computer, so then you press enter, so data flow is happening. So from application layer to physical layer, layer 7 to layer 1. So data link layer is the layer 2. So guys, what is data link layer? What is done by data link layer? So the major job is data link layer is doing physical addressing. In the network layer, you did the logical addressing, which convert data into packets. Now you are receiving packets from network layer to data link layer. So here, do the physical addressing. What does it mean? Assign in MAC address of sender and receiver to each data packets we call physical addressing. So we call this data unit as a frame. So data unit in data link layer is frame. Guys, what are the local media we use in data link layer? We can say copper, fiber, yeah. So let's go to the next slide. Two basic function: access the media frame, control how data is placed and received from media using techniques such as media access control error detection. Okay, now we comes to the physical layer. So guys, physical means it's physical. So you receive data from data links layer to physical layer with as frames. Actually, we know that these frames are also a sequence of binary, because from application layer to presentation layer there was a binary conversion. Only some data was added in each layer, but the sequence is not changed. The sequence is binary sequence. Now, what is job of the physical layer? Guys, physical layer do the data transmission using the physical devices. It can be, and also it converts these binary sequence into signals, then transmit over the local media. It can be an electrical signal in case of copper cable, LAN cable, light signal in case of optical fiber, radio signal in case of air. So if you convert into the electrical signal, you can use local media, copper, a LAN cable. If you convert it into light signal, this binary sequence, you must use optical fiber. If you convert into radio signal, you must use air. Okay. Then these electrical signal, these signals, it can be electrical signal, because physical layer do the conversion of these binary sequences to a signal. It may be an electrical signal, it may be a light signal, it may be a radio signal. So then it sends these signal using local media. It may be a LAN cable, it may be an optical fiber line, it may be a air. So then receiver side, they receive data in form of a signal. So then after that, that receiver's physical layer do a conversion, because now he is receiving from the sender. So now he should now that receiver should pop up this data from application. Okay, so then they have to do the conversion on uh, opposite direction, because sender send data from application layer to physical layer, then physical layer did the conversion of a signal, then receiver side he received it from the physical layer. Now he has to move these data into the applications. So from physical layer to application layer, the conversion should be happen. Okay guys, so here you can see a simple diagram. Here we talk about the data conversion from application layer to physical layer. So now I am going to talk about that one with a very simple example. So let's say you have an application on your computer, you type a message like hi. It's from transport layer in using some protocols, and we talk about the protocols and also using application. Then you comes to the presentation layer, you come to the session layer. Then when you come to the network layer, what happened? So it adds source IP address and destination IP address. Now the data knows where should I go. After that, data comes to data link layer. Then data converts into frame by adding source MAC address and destination MAC address. So then after data comes to physical layer. So these bits format, these bits we call binary sequence, convert into a electrical signal, a light signal, or a radio signal. You can see that from left hand side to right hand side, you can see a electrical signal, light signal, a radio signal. Then used in media, it may be the fiber cables, it may be copper cable, it may be air. Then receiver receives this data at his physical layer. Okay, now we have to do the conversion in opposite direction. So from application layer to physical layer, you add some parts. Now you need to remove these parts. From physical layer to application layer, that opposite direction, the conversion will happen. Then application, from the application layer, the receiver can see his message as hi. So we talk about data conversion from application layer to physical layer. So I think we do not need to talk about the conversion from uh, physical layer to application layer, because we already talk about the technique. So then you have to think on opposite direction. So that's how a message view from receiver side. Send message from application layer to physical layer, then convert this binary sequence into a signal. Then receiver receives this data from his physical layer. So it may be a network interface card or any other thing. So then this data flow into the opposite direction from layer 1 to layer 7, which means from physical layer to application layer. Then receiver sees the message from one of his application in his application layer. So that's how data flow from one computer to another computer, if not one source to another, one source to a destination. So guys, I think you understood about OSI model. So this is how data flow over the internet using any other media. So I think this is this idea you must have if you are willing to work as a network engineer in future. So I believe you got an idea with this video. So guys, we will bring more videos regarding networking in future. So please subscribe my YouTube channel and share this video. If you have any problem, please comment on comment line, and also follow my Facebook page. The link is in description. So hope you guys enjoy my videos. Thank you very much for watching this video.